All right, let's have a look at these.
And today I have to end 15 minutes early because I have an appointment.
Okay, just remind me, that's not something I'm generally going to remember, so just tell me whenever you need to leave, and that's fine.
Okay.
Okay. So let's look at question number 1. Let's start. In other words, before we can graph it, we kind of need to know these things. So they say graph it. I'm assuming they do not let you use your calculator here.
No.
Okay. So let's start with the x-intercepts, the first thing they ask for. What is y when we are on an x-intercept?
1.
Think of a graph.
Oh,
I'm on
0.
the x-intercept. What is y?
0.
Always. Doesn't matter what the graph is. The x-intercept means y is 0. So the way we solve these is to set that equal to 0. And now solve that equation. So what are they?
0.
That's for that
2.
one. That's for
2.
that one.
And -4.
Okay. So let's go ahead and put points on there that correspond to those, because that's going to help a lot in graphing it. -1, -2, -3, -4. All right, so we know the curve goes through that. Now, what's the degree?
Would it be 4?
What's that going to produce? An x squared, correct?
Yeah.
So we're going to have 1x squared times another x squared, which is x to the 4th, times another x, x to the 5th. It is a 5th degree equation. I do not have to multiply these all out totally to figure out what it is. In other words, I know that that is going to produce a first term of x squared. And when I multiply by x squared, I'm going to have x to the 4th. And when I multiply that by x, I'm going to have x to the 5th. Okay. What's the lead coefficient when I do all of those x's?
Positive?
Well, it's x squared. This one is going to be just an x squared, correct? It's not going to be a 2x squared or a 3x squared. It's going to be an x squared. That one's going to be an x, so I'm going to have x to the 5th. My lead coefficient is 1. You see why?
Yeah.
Okay. All right. Now we've determined the x-intercepts. the behavior at each root. By that, what they mean is, does it cross the axis or does it bounce against the axis? And that question can always be entered or answered by the multiplicity. Remember what the roots were: 0, 2, and minus 4. What's the multiplicity on the 0?
2.
What's the multiplicity on the 2?
2.
What's the multiplicity on the minus 4?
Would it be 1?
So that tells me that at minus 4, it's going through the axis. At 0, it's bouncing off the axis. And at 2, it's bouncing off the axis. You understand why? When you have an odd multiplicity, it goes through the axis. When you have an even multiplicity, it bounces off. So the only thing we have to determine is one thing. First of all, I can draw one of two curves here. Okay? I know that at minus 4 goes through the axis. So let's do that. At 0, it bounces off for sure. And at 2, it bounces off for sure. So that's one possibility. But the other possibility is starting from there, bouncing off like that. So either the red curve or the green curve would match all of those conditions. So the only thing we have to determine is the end behavior. In other words, can we figure out whether this thing comes from positive infinity, or which is the green, or negative infinity? How do you figure that out?
Would it be by the leading coefficient?
Well, what you really do is, since we're looking in this direction, right? We're looking for left-hand end behavior. We're going to substitute negative infinity for x. So here's what you have. You have y equals negative infinity squared times negative infinity minus 2 squared times negative infinity plus 4. And the answer to our question is this equal to positive infinity or negative infinity? Well, what's the first term? What's negative infinity squared? Negative times negative is positive.
Okay.
And infinity times anything is infinity. What's negative infinity minus 2 squared?
Would it be infinity?
Good. And finally, what's negative infinity plus 4?
Infinity.
No.
Oh, negative and
Negative infinity. In other words, you can add whatever you want to negative infinity. You're still at negative infinity. Okay? So now, if you multiply those three together, you get negative infinity, which means that is the correct place to start. as x goes to negative infinity, y goes to negative infinity. And remember, I only had two choices here. So I found the right one. Now, it probably means that the best way to do this problem was to figure out the end behavior first. Then I wouldn't have had to do two graphs. I would have known that I started from down here and satisfies everything else in my equation. Satisfies the multiplicities, it satisfies the x-intercepts, and it satisfies the end behavior. And it also satisfies, the multiplicity, which determines whether it goes through the x-intercept, that's an odd multiplicity, or it bounces off the x-intercept, that's an even multiplicity, always. If it's x to the fourth, that's an even multiplicity. It's going to bounce off the x-intercept. All right. These are fairly sophisticated. Let's start with the x-intercepts and multiplicities.
So it'd be 0, 4.
Well, hold on. Multiplicity of the 0.
3. And then
Multiplicity of the 4.
2. Then minus 2 with multiplicity of 1. And then 7 with multiplicity 4.
Now let's figure out the degree. Really, the only thing you need to do to figure out the degree is add that to x squared to x to the fourth.
10.
And we've already answered. Oh no, we haven't. What's going to be the leading coefficient?
1.
All right, so let's see if we can graph this. We're going to need one further thing, and that's end behavior. But very first thing we should put on there are the x-intercepts. Okay. What's the next thing we want to do?
Graph it.
End behavior. If we figure out end behavior next, we won't have to come up with two different curves. If we figure out end behavior next, we will know whether it starts from down there or up there. It's going to start from one or the other. So let's do negative infinity, because that's always as x approaches negative infinity. So as x goes to negative infinity, what happens to this function? I'm going to draw it down here. Here, I'm just going to substitute, and this is the way to do it. You see what I'm doing, right?
Yeah.
What's that equal to?
Positive infinity?
What's negative cubed?
Negative infinity.
All right, so that term's negative infinity. What's the second term?
Infinity?
What's the third term?
Negative infinity.
And what's the fourth term?
Infinity?
Now what's the product of all four of those?
Would it be 0?
Positive infinity.
Okay.
First of all, it's very, very impossible to get from infinity to 0. Okay? Even if I said to you, what's infinity times 0, the answer might not be 0. That's actually a very sophisticated mathematical concept. It's called an indeterminate, but the premise is that infinity times anything is not 0. Okay? It's infinity because you have one positive, or excuse me, you have two negatives and you have two positives. Well, if you have a negative times a negative times a positive times a positive, you have a positive. That's all we're doing. You don't even need to consider the symbol infinity. You just are multiplying the signs. All right, so what that tells us is that when x goes to negative infinity, y goes to positive infinity. So I'm starting from there. Not starting from down below. That would be starting from negative infinity. Now the rest of it I should be able to figure out. What's the multiplicity at minus 2?
Is it bounce?
What is the multiplicity at the 0 of minus 2?
Oh, 1.
Okay. What does that tell you? Does it go through the x-axis or bounce?
It goes through.
Now, what's the multiplicity at 0?
3.
Does that go through the x-axis or bounce?
Bounce.
No, if it's odd, it goes through. If it's even, it bounces. It's real straightforward. Only two choices. That's odd. So it goes through. Now, add 4, what's the multiplicity?
2.
So does that mean it bounces or goes through?
Bounces.
And finally, at 7, what is the multiplicity?
4.
Bounce or go through?
Bounce.
There's your curve. Now, I don't want to give you any other principles based on that curve. It would be misleading. But that's the way you do it. In other words, the only thing missing on here that they really should have is end behavior. Because I don't know how they expect you to draw it without knowing end behavior. Is that a term you even know?
Yeah.
Okay. Yeah, you would have to. Because the other alternative for this thing would be if the end behavior went like that, and then it would go like this. So that's the only difference between the two curves, is how the left-hand end behavior is. So you always have to answer left-hand end behavior. Now you could do right hand, but left-hand end behavior goes from left to right, which is the way most people kind of think. So that's the way generally we want to go, is left-hand end behavior. All right, number 3. Okay, we're good. I was thinking we started at 2 o'clock. We started at 2:30. So we're good. Plenty of time. What are the x-intercepts?
0 and 3.
And what's the multiplicity on the 0?
1.
What's the multiplicity on the 3?
3.
What's the degree?
4.
What's the leading coefficient?
-1.
Very good. I would have said 1. You're right, it is -1. Okay, so we have an x-intercept there. We have an x-intercept there. They're both odd, so what does that mean the curve's going to do at those x-intercepts? It's going to bounce or go through?
Go through.
Okay. So what's the next thing we need?
The end behavior.
Okay. Which means as x goes, all we have to do is one side, really. Start from left to right. As x goes to negative infinity, what does y go to? So here's how you figure it out. You got negative infinity, right? That's minus x times negative infinity minus 3. In other words, all you do is substitute negative infinity for x. What's that?
Negative infinity.
It's negative times a negative.
Positive.
What's this?
Oh, positive.
What's negative infinity times negative? Remember, the only term that matters is that. You can take that minus 3 and throw it in the river. You don't give a hoot about minus 3. The only thing you care about is what is negative infinity cubed? What is negative infinity cubed?
Negative infinity.
Now you got positive infinity times negative infinity. That's
Negative.
where we're coming up from. In other words, we're coming up from down here. We're not coming up from above the x-axis. We're coming up from below the x-axis. Now, what do I do when I get to there? Go through or bounce?
Go through.
Got to somehow get back to there. Go through or bounce?
Go through.
Now, that is a very rough approximation of the curve. If I were to put this into Wolfram Alpha, it would look a little bit more bumps involved. It might look something like this. But it's basically going to have this appearance. And you can see that you only need 3 things. You don't even need the degree or this. I don't even know why they ask you about both of those. What you need is end behavior, and you need whether it goes through each zero or bounces. That's it. Those three things will allow you to graph it. Before we keep doing same stuff, let's do number 7. And then if we have time, we'll go back and do 4, 5, and 6. To me, 4, 5, and 6 are exactly the same as 1, 2, and 3. Do you agree?
Yeah.
It's just with different degree polynomials and different x-intercepts and different end behavior. And I don't know why they keep asking this question. That first coefficient is either 1 or minus 1 in every single one of these. At least you'd think they'd make it 2. In other words, it wouldn't take much to make it 2. All you'd have to do is put a 2 in front of one of these x's. But all 6 problems, they left it either 1 or minus 1. All right, so we're going to do number 7. Hold on. Bounces off the x-axis at 1, 0. What does that make that factor? Hold on, I got difficulties here. Not sure what's going on. Let's try this again. All right. So what does that mean about the factor?
Well, it would be an even multiplicity, right?
Okay, that's good. We'll just assume 2. But what does that mean? It means the x-intercept is at 1. What does that mean about the factor?
It would have to be x minus 1.
Good. Now it crosses the x-axis at both 4 and 3. So what would be those two factors? Excuse me, 4 and negative 3.
X minus 4 and x plus 3.
And it crosses the axis at both points, meaning what?
It would have to be an odd.
Correct. And they don't really tell us whether it's 1, 3, or 5. So I would assume that the only thing we can assume is that it's 1. So that's our function. And it also goes through that point. That is not quite our function. That's our function. In other words, all of these things they say are true would be true even if this entire function was multiplied by some constant. All that would still be true, that would be true, and that would be true. Now, the reason they give us this point here is so that we can calculate A. Well, y is going to be minus 162 equals A times minus 2 minus 1. You see what I'm doing?
Yeah.
Minus 2 minus 4 minus 2 plus 3. That's going to allow us to solve for A. So what do we got here? We got, let's see, that's minus 3 squared, which is 9. That's minus 6. And that is 1. So we really have minus 162 divided by minus 54, which is exactly 3. So A is 3, and our equation is 3 times x minus 1 squared times x minus 4 times x plus 3. That satisfies everything in that question. It bounces off the x-axis at 1, 0. It crosses the x-axis at 4 and minus 3. And it goes through this point. Whatever that curve looks like, it goes through the point minus 2, minus 162.
All right.
That's about as hard as they get. Frankly, I'm shocked at how difficult the problems you're getting are right now.
I think that's it for today. I think I have to leave.
Okay, that's fine. Lock on. I will talk to you next time.
All right. Thank you.